going to look at the Mann-Whitney U-test. So this is a non-parametric test which is equivalent to the independent t-test. Okay, when we talked about the t-test, we said the t-test is used to compare two independent groups. So we have maybe females and males, and we want to compare maybe in terms of performance how they are performing in class. We want to find out, is there a significant difference in terms of performance between male and females? So we can run a t-test to test that hypothesis. Now, if the data does not meet the condition for the t-test, we can use the Mann-Whitney U-test to test the same hypothesis. Okay, so this Mann-Whitney U-test is used to test the hypothesis when the data violate the conditions for the t-test. Okay, so it is used when we are comparing or when we have ordinal measurement of the dependent variables. So when we are testing this hypothesis, the steps for testing the hypothesis remain the same. First, we need to state the null hypothesis. After we have stated the null hypothesis, we calculate the test statistic. After calculating the test statistics, we need to determine the critical value, then compare the critical value with the test statistics that we have determined at first. Okay, so we have these formulas that we use for the Mann-Whitney U-test. So we have the U values. We have U1 and U2. So these are the test statistics that we are going to be determining. Okay, so these, okay, and we use the smallest U value. After you have calculated, we use the smallest U value to as a test statistic. Okay, the smallest U value is used as a test statistic. So we have this U value. The first U1, you say U1 is equal to N1 times N2 plus N1 plus times N1 plus 1 over 2 minus summation of sample ranks. Okay, minus summation of sample ranks. So N2, U2 is also given by the similar formula where we say U2 is equal to N1 plus N2 plus N2 times N2 plus 1 over 2 minus the sum of the sample ranks. So where we are given this N1 represent the size of sample 1 and N2 represent the size of sample 2, whereas the other one represent the sum of the sample, okay, the sum of sample 1 ranks, and other 2 represent the sum of sample 2 ranks. So these are the data that we have. Then we choose the smallest of the U values. Okay, we choose the smallest of the U values as a test statistics. Then from there, we find the critical value using the Mann-Whitney table. So the critical value is coming from the table. Okay? So when the computed value is smaller than the critical value, the outcome is significant. So if we find the critical value, okay, or the test statistics is smaller than the critical value, then the finding or the outcome is significant. That means you cannot reject the null hypothesis. Okay? Or sorry, you can reject the null hypothesis when the test statistics is smaller than the critical value. You reject the null hypothesis. Okay, you reject the null hypothesis. So we are going to run through an example of the Mann-Whitney U-test. Okay, we are going to run through that example. Yeah, so we have this data. We have this as an example. So the following are the scores of the two groups. Researchers wish to know whether there is a significant difference in scores of the two groups. So we want to know if there is a significant difference between these two groups. Okay, so this is more like we are going to take group 1 as the test score or the exam results for girls, and group 2 as exam results for boys. And now we want to compare if there is a difference in terms of performance between these two groups. So we are going to use the Mann, Whitney test. So the first step, we are going to state the null hypothesis. Okay? The first step, we are going to state the null hypothesis. Okay? So the null hypothesis is going to say there is no difference in scores of the two groups. That means the sum of the ranks for group 1 is no different than the sum of the ranks for group 2. The alternative hypothesis is going to say there is significance, or there is a difference between the scores of the two groups. That means the sum of the ranks for group 2 is significantly different from the sum of the ranks for group 1. So we have these differences. Okay? After that, we need now to calculate the test statistic. So we are going to calculate the test statistics using our formula. So we need to calculate the value of U1 and the value of U2. Then we are going to take the smallest value as the test statistic. So we have N1 times N2 plus N1 times N1 plus 1 over 2 minus summation of R1. So that is the ranks for group 1. So first, we need to determine N1 and N2. What is the size? What are the sample sizes? So from the data that we are given, we look at the data which we are given. So for group 1, how many do we have? In group 2, how many do we have? So N1 is going to be, you count these, how many are they? 1, 2, 3, 4, 5, 6. And N2, they are also 6. So N1 and N2 is 6. And yeah, that is the sample size for the two groups. Then from there, we need to find R1 and R2. Okay, so to find R1 and R2, we need to sum these groups. We need to rank them first. After we rank them, then we can sum. We can sum the ranks. So we are starting from the smallest to the highest value. So the smallest value is going to be ranked as 1, and we'll follow that order until to the last one. So let's start. Which one is the smallest value in our data set? So the smallest value is 12, and 12 is going to be ranked as 1. Okay, so we have this data which is ranked here. 12 is going to be ranked as 1, whereas 18 is going to be 2. Number 3 is going to be 24. We have 28 representing number 4, and we do the same up to the last value. So we are going to have these. So after you have ranked this data, you need to sum up the ranks. So when you sum up the ranks for the first data, it's going to give you, so when you sum the ranks for the first group, we are going to have 26.5, and when we sum the ranks for the second group, we are going to have 51.5. So these are the ranks. This is R1 and this is R2. Okay, we have R1 here and R2 this side. So we have found our values. So we are just going to replace these values in our formulas. Okay. So we have N1, which is 6. So it's going to be 6 times 6 plus 6. When add 6 plus 7 is going to give you 6 plus 1 is going to give you 7. So this is where 7 is coming from. It's coming from 1, 6, which is n1 plus 1, which is 6 plus 1, giving us 7, times over 26 minus over 2 minus 26.5, which is R1. Then when we do that, it's going to give us 30.5 as U1. Then U2 we are going to calculate using the same formula. It's going to be N1 times N2 plus N2 times N1, N2, plus 1 over 2 minus R2. So we replace the values. It will be 6 times 6 plus 6 times 7 over 2 minus 51.5. So when we do that, we are going to find NU is going to be 5.5. Okay? So now we compare the two values, U2 and U1. U2 is equal to 5.5 and U1 is equal to 30.5. So we are going to take the smallest value, which is U2, as the test statistic. So our test statistic is going to be U2. Okay? Our test statistics is going to be U2. Then from this, we are going to go to the table and find the critical value. Okay, we are going to go to the table and find the critical value. So let's try to go to the table. So this is the table that we have. Okay, this is the table that we have, and this side we have N1 and this other side we have N2. So let's try to find these values. Okay, so N1, first you have to be careful. We have these alpha values that are given here. Okay, we have these alpha values that are given here. So N1, where alpha value is 0.05, we're going to take this one. So they have N1 this side and N2 this side, and the alpha value is 0.05. So we're going to take this line and find our N value. So the critical value from this table is going to be 5. Okay, it's going to be 5 from this and this angle. We are getting 5. So since we find the critical value to be 5, we compare it with 5.5. So the critical value 5 from the Mann-Whitney table is smaller than the test statistics. So since the test statistics is greater than the critical value, we fail to reject the null hypothesis, and we conclude that the distribution of the two scores are not different. So the critical value is less than the test statistics in this case. So we fail to reject the null hypothesis with that conclusion. Thank you very much, and if there's any question, you can reach out to me and I'll be able to help you. Thank you.